We have the question, find the power series solution of the differential equation d square y by dx square plus x into dy by dx plus x square plus 2 into y equal to 0 in powers of x. We have already seen that a power series at a point x naught is written as y is equal to sigma n equal to 0 to infinity a n into x minus x naught whole raised to n. This is a power series about the point x naught. Now what I need here is a power series solution in powers of x. That means our x naught should be equal to 0. In short, I need a power series solution for the given differential equation at the origin or at the point 0. Now if I need a power series solution, we have seen a theorem. The power series solution exists at a point only if the point is an ordinary point. That means if I need a solution, power series solution in powers of x, my origin or else the 0.0 should be an ordinary point. What is P1 of x and P2 of x? Let's see what this is already in the equalized equal and normalized form. So there's no need to change it. Our P1 of x is x, and P2 is x square plus 2. Both of them are polynomials and are analytic everywhere. That means all points are ordinary points, and definitely we are going to get a power series solution at the point x not equal to 0. So I'm going to cut this off. We don't need that. So here goes our explanation. Now we'll start. The first step is always putting y is equal to sigma n equal to 0 to infinity a n x raised to n. This is our solution. Now we need y dash and y double dash to go into this equation number 1. We have already seen how we can write y dash and y double dash. That is sigma n equal to 0 to infinity, and let's just differentiate the inner term of the summation. That is, we get n into a n x raised to n minus 1, and y double dash will be sigma n equal to starts from 2 to infinity, again n into differentiating this term, n into n minus 1 into a n x raised to n minus 2. Okay, now we are going to substitute all these terms into equation number 1. We have sigma n equal to 0 to infinity n into n minus 1 a n x raised to n minus 2 plus x into y dash is sigma n equal to 1 to infinity n into a n x raised to n minus 1 plus x square plus 2 into our y, which is sigma n equal to 0 to infinity a n x raised to n equal to 0. Now let's multiply these and the terms. We have sigma n equal to 0 to infinity n into n minus 1 a n x raised to n minus 2 plus this will be sigma n equal to 1 to infinity. I am taking the x inside, n into a n x raised to n plus, I am expanding these terms, sigma n equal to 0 to infinity, and I am taking this x square inside. I have a n x raised to n plus 2 plus 2 into sigma n equal to 0 to infinity a n x raised to n equal to 0. Okay. Now the next step is to make all the powers of x equal. That is, we are going to make all the powers of x to x raised to n. We have an x raised to n minus 2 here. That should be changed to x raised to n. Here also n plus 2 should become n. Here there's no need for any change. So let's see how we can do that. Suppose what I need is n minus 2 should go to n. Let's put n minus 2 equal to m. Here m is our dummy variable. So if n minus 2 is m, what will be n? N will be m plus 2. Okay. Now let's try writing this term. This will be sigma. What happens to the summands? Here the initial starting point is 0. So when n is equal to 0, our m will be, did I do anything wrong? No, that's right. When n equal to 0, m should start from One second. Okay, there was a small mistake here. This was n equal to 2 to infinity. Okay, this is again 2 to infinity. So, okay, now it's right. When n equal to 2, our m becomes m equal to 0. So this is sigma m equal to 0 to infinity. When n equal to infinity, m is also infinity. Now instead of n, I am going to put m plus 2. N minus 1 will be m plus 1. A n will be a m plus 2 into x raised to m. Now what I'm going to do is I'm just replacing this m with n. Just simply replace m with n to get. So this term will become now sigma n equal to 0 to infinity n plus 2 into n plus 1 a n plus 2 x raised to n. Okay, now this is our first term. First term has become changed to this term. If you have any doubt, you can just expand and see the summation and the summation, the series. Both these series are the same things. Just we'll try with first term. When n equal to 2, here the first term will be 2 into a2 into x raised to 0. So 2 into a2 will be the first term here. Let's try here. Here when n equal to 0, we have 2 into a2 again. Okay, so both these series are the same. Okay, now we have changed the first term into this term. Second term doesn't need any change because it's already in x raised to n. Now let's come to the third term. Third term needs a change. Coming to the third term, this is our third term. Now what will that become? Let's write it over here. As before, what I need is n plus 2 should be m. Okay, so my n is going to be m minus 2. Sigma, what will be the limits? N is equal to, when n equal to 0, m will be equal to 2. So that is m equal to 2 to infinity. 2 to infinity. an instead of an, I am going to write a m minus 2 and x raised to m. Now what? Now we have to just replace m with n. So this will be sigma n equal to 2 to infinity a n minus 2 x raised to n. Now let's once again write the whole equation. Now our equation is going to be sigma n equal to, instead of 2 to infinity, I have changed it. It is 0 to infinity n plus 2 into n plus 1 a n plus 2 x raised to n plus second term is as such sigma n equal to 0 1 to infinity n into a n x raised to n plus, now third term has a change, that is sigma n equal to 2 to infinity a n minus 2 x raised to n. Last term is the same, sigma n equal to 0 to infinity a n x raised to n equal to 0. Now we have changed all the powers to x raised to n. Now that is all set. Now the next step is to treat with the summations. You can now see that this is the largest summation series in the given equation. This one is the largest summation series because it has more than terms which are present in this one or in this one. Okay, here also the same situation. Here also summation runs from n equal to 0 to infinity. What is the problem here? Here we don't have, one term is missing, that is n equal to, doesn't start from n equal to 0 to infinity but starts from n equal to 1. That is one term is less here. Here two terms are less. That is n equal to 0 is also missing, n equal to 1 is also missing. So this is the shortest summation series and these two are the largest ones. Now what we are going to do is we are going to convert all the summation to the shortest one. That is, we need the summations to run from sigma n equal to 2 to infinity so that we can group all the terms. Now we are going to do that. That is a simple procedure. What you have to do is you have to just expand the first two terms of this series. That is, we are going to put n equal to 1 and n equal to 2 in the series and see what happens. Now that is, when n equal to 0, we have 2 into a2 plus n equal to 1 will give us 3 into 2, which is 6, n equal to 1, a3x. Okay. All the rest of the terms will go under summation. That is, sigma is going to run from n equal to 2 to infinity, n plus 2 into n plus 1, a n plus 2 x raised to n. Plus the same technique goes here also. We have to expand n equal to 1 and see what happens. A 1 into x plus all the rest of the terms goes under the summation 2 to infinity an x raised to n. And this term is going to be the same, sigma n equal to 2 to infinity an minus 2 x raised to n. Last term again we are going to expand 2 times a naught plus a1x plus the extra term sigma n equal to 2 to infinity an x raised to n equal to 0. Okay, now what I have done here is I have grouped all the constant terms together. I get a 2a2 and 2a0 from here to a2 to a0. From here I'm having a 2a0 here and I'm having a 2a2. I have grouped those two terms together and I have grouped all the x terms. Here 6a3x, a1x is here, and also from here I'll get a 2a1x. So I have a 3a1x. Okay, all other terms, that is all the coefficients of x raised to n is comes under the summation sigma n equal to 2 to infinity. Now this whole power series is equal to 0 will imply that each coefficient is equal to 0. That is 2a2 plus a0 is equal to 0. And this coefficient of x is equal to 0 and the whole coefficient of x raised to n is also equal to 0. And from there we are going to find the unknowns. That is our coefficients. That is the ans. We are going to find our ans. Now let's see how we can do that. Now this was our final answer from the previous page, 2 into a2 plus a0 plus x into this whole thing. Now what we are going to do is we are going to equate the coefficients. Now let's start with the first one, that is the constant term. Equating that to 0 will give us a2 plus a0 is equal to 0. That is a2 is equal to minus a0. Okay. Now from here I am going to get a3 is equal to minus a1 by 2. 6a3 plus 3a1 is equal to 0, and from that I am calculating a3, which will give me a3 equal to minus a1 by 2. Now if I know my a0 and a1, I am going to get automatically all other coefficients. So here practically there are only two unknowns, which are a0 and a1. Now let's see what comes from the rest of the summations. Equating that coefficients to 0, we'll have n plus 2 into n plus 1 into a n plus 2 plus n plus 2 into a n plus a n minus 2 is equal to 0. Here we are going to find what a n plus 2 is. A n plus 2 is equal to minus of n plus 2 into a n plus a n minus 2 whole divided by n plus 2 into n plus 1. Okay, this is my a n plus 2. Now I am going to put 1 by 1 as n equal to 1, 2, etc. and find say sum up to a4, a5 and a6. I already know what a2 and a3 are, even though I don't know what a0 and a1 is. I have calculated my a2 and a3s. So let's start with n equal to 2, because n equal to 0 will give me a2 and n equal to 1 is going to give me a3. So I am going to start with a2. a2 is equal to, n equal to 2 will give me a4. a4 is equal to minus 4a2 plus a0 divided by 4 into 3. Okay, a4 is equal to, we'll get substituting for a2, I am substituting minus a0, substituting and calculating, I'll get 3 by 12 a0, which is a0 by 4. So a4 is equal to a0 by 4. Now let's substitute n equal to 3 and see what I'm getting for a5. a5 is equal to, n equal to 3 means minus 5 into a3 plus a1. Now let's come back to our problem. Let's start from where we have left off. When n equal to 3, I'm trying to calculate n equal to 3. We get a5 is equal to minus, I'm substituting here, minus of 5a3 plus a1 by 5 into 4, which is 20. Now I am calculating and I'll get, for a3 I'm substituting, what was a3? Minus a1 by 2. Substituting and calculating, I'll get 3 by 40. Similarly, I can do one more term, that is n equal to 4. Substituting n equal to 4, I'll get a6. a6 will be this value. Substituting in the above equation, I am getting the, this is what we call as recurrence relation. I'm substituting here, and from here I am getting this value, and for a4 I am substituting a0 by 4, substituting plus instead of a2 I am substituting minus a0 and calculating, and I am getting this value. Okay, this is how we can find the coefficients. Actually our two unknowns are a0 and a1, the rest are depending on a0 and a1. Now with all these things we can substitute in the power series and find the solution. Now let's try that. Okay, now we know that y is equal to a0 plus a1x plus a2x square plus a3x cube plus a4x square plus a5 a4 x raised to 4 x raised to 5 plus a6 x raised to 6 plus etc. I've written this many terms because I have calculated up to a6. That's why it's okay if you calculate just up to 4 terms also. Depending on your time and marks, you may do that. This is equal to, I don't know what a0 is, and so I am writing the same thing. I don't know what a1 is, I am writing the same thing, plus. Now I had calculated a2 as, a2 was minus a0 x square plus, I got my a3 as minus a1 by 2 x cube plus a4 was 1 by 4 a0 plus a5 was 3 by 40 a1 plus etc. Okay, x raised to 4 is here, and then x raised to 5 is also here, plus etc. I can also substitute a6 and a6 also, no problem. Now what I am going to do is I am going to combine all my a0s. So a0 into 1 minus x square, then what, x raised to 4 by 4 plus etc. Now I am going to combine my a1s. a1 into x minus 1 by 2 x cube plus 3 by 40 x raised to 5 and so on. So this is my final solution. This is my power series solution for the given linear differential equation. Power series solution at in powers of x, that is at x equal to 0. Okay. So once again we are just remembering our steps. Step 1 was substituting the values of y, y dash and y double dash. Second step was making the powers same, that is converting all the powers to x raised to n. Third term was find the least least summation series and change the summation powers to that. So if in this case it was from sigma 2 to sigma over n equal to 2 to infinity. Depending on the problem this might change. If n equal to 1 is the smallest power series summation series appearing, so then you will have to change the full summation to sigma n equal to 1 to infinity. This was the last thing. Then comes the comparison of coefficients. Comparing the coefficients and finding the answers. And finally substituting. Last step is of course our substitution. Substitution to y. Thank you.